Okay, we have seen the boilerplate constructor, how we want to make that constructor. I mean, Java has a constructor that makes, but it's not useful. We have one that's routine. In fact, um, Eclipse, I think, has a menu option, create constructor from fields. Okay, a lot of languages, the constructor we made, it comes with a language, Scala, Racket, a bunch of them, you just define the fields, you get a constructor that takes in exactly that many inputs and makes the corresponding object. Okay. Um, we saw a toString. Java has a built-in toString. It's never the useful one that you want. Let's go ahead and write a useful toString. Um, and we saw a sort of new idea of maybe, hey, maybe the toString looks like actual code. That's convenient. It's nice. Okay, so now we're going to go to something that is not covered in basic intro classes, overriding equals. I mean, it could be covered there, and it feels like maybe it's there. Let's go ahead and I'm going to start with how you don't override equals, and then we'll see what's wrong with that and come back and actually do that. Okay, so let's go down here. And first of all, before we even get into the code, what do we want equals to do? Why do we need it? Well, first of all, let's say we're going to be writing some other, so here's why we're going to need to override equals. And I should say off the bat, this is going to be geared towards immutable data. If you have mutable data, but I want to be able to say things in the future if I were to add a new method to this class book. So maybe I'm going to go ahead and make a method that just sort of abridges a book by taking out some of the pages or something like that. So I might have, once I've written that, I want to say, hey, assert that b1.abridge, whatever that maybe cuts the number of pages in half. I don't know. And I want to say, hey, I want to say that when you call b1.bridge, you get back a whole new book, and the book you get back should be equal to new book with the same title, Cat in the Hat, and the same author, but the number of pages might be, again, cut in half, and I have to think about what 37 is cut in half if I'm bound to ints. Good thing I'm doing these test cases first. Maybe we're going to say it's rounded up a little bit. We take the ceiling of that. So, gosh, why did I choose a number of 37? It's harder for me to cut in half in my head. It's 18 and a half, round up, 19. And it's still going to be copyrighted. Okay, so yeah, I want to go ahead and do this. Say, hey, this is the result of calling a bridge. Now, what a lot of people tend to do is they'll call b1.abridge, put the result into a new variable, and then they'll assert that, b2 maybe, they'll assert that, hey, b2.number of pages is equal to 19. And they probably forget to say, hey, you should also be asserting that b2.title is still b1 title, and b2 author is the same as b1 author. That is part of the correctness of a bridge, is that it shouldn't be changing the title, nor the author, nor the copyright status. And if it does, it should be failing. So this is nice. This is going to go ahead and take care of all of that for us. Okay, so we want to go ahead and, just to do testing, we want an equals that works on all the fields. It just compares two objects field by field. Okay, and again, if you have immutable data, this is exactly what you want. This is how string works. You have two strings in Java. When are they equal? Look at them field by field, character by character. Make sure everything is equal. And then we call these two strings equal. Okay. So yeah, I want a boilerplate equals method that just checks all the fields. So I'm not going to put this because I don't have an abridge, but I can go ahead and make some tests. I can just go ahead and say, hey, b1.equals, b1 had better be true. Okay. Assert. Okay, and I can also assert that b1.equals of, hey, I'm going to make sure that two, different objects, but with all the same fields, I want those to be considered equal. So again, I'm going to go ahead and assert that b1 equals that. So I'm asserting this. And of course, if I want test cases, I want to make sure that the code, whatever, I want to go ahead and assert that. I don't want to just have only tests for things that are true. b1.equals of, I need someone, I should probably have another book that I'm going to go ahead and make up here, because I want good test cases in general. I'll try to have a book that's sort of minimal. When I'm about test cases, I always think of borderline test cases. What's the shortest valid title? Maybe. And now I'm going to think about, this is actually constraints I should have thought about in my constructor already. Hey, taking a string for the title. What sort of strings are allowed? Is it nullable? Is it a string of length 1 okay? Sure. Is a string of length 0 okay? Maybe the empty string is not a valid book title. Go talk to their publisher, whoever's you're modeling books for, and ask them, hey, what are the constraints on a title? Okay. Can a book have 0 pages? Maybe decide it can. Yeah. Okay. So have some things like this, and I might want to go ahead and check that this is not true. So I can use, again, a better framework would have some sort of better tests. In fact, JUnit has assert equals. Assert equals won't work unless we have an equals that is already working. Okay, so, okay. Anyway, great. Let's go ahead and now actually get to what I've been talking about. Let's actually write equals. And you're like, this is going to be pretty dang simple. And in fact, I can go back and let me go over here, grab, I sort of said we had a template for all the book handling functions, and that's certainly true here. I can copy and paste that. Let's go back into the thing that we're writing. Okay, I want to write equals. What's the return type for equals? Boolean. It's going to be a public method, equals Boolean. Equals is given a book and another book. What should we call the book we're comparing to this book? That seems like a good idea. Okay, and yeah, we certainly have these fields here, and in fact, we can we have to, now that we have 2 books coming in as inputs, we have those 4 fields. Actually, we have those 4 fields for each of them. So let me go ahead and the template would suggest having, for all the things of that type, pull out the fields. That's the thing here. We're going to actually need all that, except half of these are going to be, oops. Okay, so now we have 8 pieces of information. We have 2 strings, another 2 strings, 2 ints, and 2 booleans. Easy. This should be easy peasy. Return this dot title those are strings, right? What sort of methods do we want to call on strings? Oh, dot equals is one that we can call on strings and makes sense here. Okay. And another string here called dot equals. Fix up my typos that I type in. Yeah, okay. By the way, I didn't go ahead and put a purpose statement on here because, who needs a purpose statement? This is too trivial. Well, it is good to know that this is an immutable equality test. So rather, equality is considered component-wise. Okay, this .num pages is an int, so I don't call it .equals because, I wish I could, but Java has this fundamental asymmetry about primitive types and all the object types. So I can't say .equals here unless I were to wrap it and do a bunch of other stuff. Okay, so let me just go ahead and use equal, and finish up with this dot copyrighted equal that dot copyrighted. Okay, sounds good. That's going to be my code here. That seems pretty straightforward. Why are we even bothering talking about this? First of all, let me just mention the AND operator and the equal operator. What's the precedence between and equal? oh gosh, I mean, I know that my dear Aunt Sally or PEMDAS or something like that, I know that multiplication is done before addition, but are we checking of something and something, are we checking something and something and something, that this whole Boolean is equal to an int? I don't want to be saying that. Am I saying it? Gosh, I guess I can go look up all the precedents. No, don't bother with precedents. Put in parentheses to make it clear. I think it would be right the way it is. They sort of designed the precedents to work conveniently, but part of me is just like, why count on that? Make it clear. If I ever get a bug, I don't want to have to look at that and say, gosh, could that be causing my bug? And go off on some wild goose chase for a moment. Okay. Anyway, easy peasy. I didn't put in the Java doc because why, this is an override. Though, as an object-oriented programmer, whenever we talk about overriding equals, a little flag needs to go up in our mind. And it's not just Java, this is any language. You need to remember that if you override equals, you must override hash code. And now I can go ahead and compile. I'll get an error. What's the error we got here? Method does not override. What? Oh, okay, so here's the real problem. Equals up in class object. That's where we overrode this, right? Up in class object equals said, hey, is the current object equals to something else of type, not type book. Type book wasn't written back when they wrote class object in the basement of Sun Microsystems. Yeah, the signature for override has to be another object. That is what's going to cause us problems, and that's what this video is about. So now we can compile, but now, of course, we have a different issue. Hey, any object doesn't have a field called author. So, okay, gosh, do I need to cast it or something like that? Oh, yeah, oh my goodness, what's going to happen here? So here's what we really need to do. First of all, we need to say, what if we can't cast it? I shouldn't throw an exception, a class cast exception, if somebody takes a book and calls, hey, are you equal to system.in? The answer should be false. The book is not equal to system.in. So if these are different types, we should return false immediately. So let's go ahead and put that in. If this dot, gosh. And now I need to go ahead and look this up because I can never remember this name so often. I'm going to go ahead and say, hey, if this dot class is not equal to that dot class. And I'm going to actually use get class, okay? So by the way, what is get class? Get class is a method defined on all objects. It takes in an object and returns the class of that object. Wait, what's the return type? Return types can't be types. Return types are values. They are objects. Oh, it turns out there's a class. And class represents, an object of that type represents a Java class, and all the information about that Java class is part of the reflection that goes on here. So I'm going to go ahead and go to here, and I'm going to say if they're not equal. Okay, so how do I want to do that? If they're not equal, return false. Else, and now I can go ahead and have my return statement here that I want. Okay. And that gives me something closer there. Okay. We still have some issues. What if the thing that is passed in, can this ever fail? Can this ever fail? Whenever you call a method, when can a method fail? Oh, if the reference is not actually in one of those objects, if it's null, if it's a null reference. Can this ever be null? The fact that you reached this method at all means, hey, Java, you had an object, you called it one of its methods, the .equals method on something. It went and looked up that method. If it was null, we wouldn't, and you called null.equals of something, you'll get a null pointer exception right away. We wouldn't reach any code. So this can never be a null reference. Okay. However, the thing that was passed into equals, that could be a null reference, so we need to do another check here. If that is null, then return false. Okay. Now I think we're much better. Let's just take care of what's this return statement here. We have this little glitch now when we try to compile. We still get an error. What does it not like here? Class. No, I want to set a breakpoint. Compile, get an error. Oh, I just had my parentheses wrong. Dot equals that dot get class. Oh, another one's expected all the way over there for that not. Okay, good. So we compile. Well, we're going to get something else here. Am I finishing off that class? Okay, here's the error found. What is the error? Cannot find type. Oh, we're back to this casting thing. Again, that is a type object. But if I go ahead and reach this, it's because this dot get class and that dot get class are the same. If I reach this, it's only because I know that that really is a book object. So, now I can go ahead and I'm going to do the cast. And I just want to do it once. I could do the cast here and here and here and here. That's going to be a pain. I'm going to go ahead and just sort of say book that. And I'm just, this is just to make the compiler happy. And now I'm going to talk about, compared to that, same object, just a different name for it once past the type checker. Okay. So now I have an equals method that actually works and will pass all those assertions. I hope. Let's go ahead and see if it passes our assertions. Good thing I had those test cases written, because this was not the easy method I thought it was going to be. Go ahead and run this. It's a void method, I need a semicolon. No assertions happened. Again, if I'm not sure I'm running with assertions enabled, I might go and introduce an error just to verify that it causes an error. Okay, there's one other thing that people tend to do with an equals method, and that is a fast path. Sometimes when people call equals, they'll pass two book objects. Sometimes those book objects might be more than just equal field for field. They might be equal, the identically same object. That happens enough, it might be worth adding a little fast path here. It doesn't cost much if it's not true. So if this equal that as pointers, then return true. Okay. And compile, we're still going to pass all the tests. And now, this one is not needed for correctness, but it is an optimization that seems pretty plausible, might win us some time. So this now is a standard boilerplate equality. You know, by looking at the different fields, I could write a program that generates this. I wish more IDEs had. I wish there were a generate equalities from, or generate equals from fields. An equals it does an override. Does a field by field comparison. That might be worth mentioning. In some sense, you can think of this as a deep equals. Sometimes people use that terminology. Okay, great. So we've figured out how to override equals, except there's one more little caveat. If you override equals, you must override hash code correspondingly. What does that even mean? Let's go to the next video.